Welcome to the deep dive. We're here to cut through the noise and get to you those critical insights. Have you ever been stuck trying to figure out exactly how some piece of data in a complex system got, well, got to where it is now? Or maybe you're thinking about designing an app that needs to handle totally new kinds of reports, maybe years from now, without having to rip out the whole data storage. Today, we are diving deep into a design pattern that hits these challenges right on the head: event sourcing, and specifically how it works with Spring Boot microservices. Our mission to really unpack this powerful approach, understand why it's becoming so popular in these big distributed systems, and give you a real sense of what it actually takes to use it effectively. It's kind of a fundamental shift in how we think about data. Really, it opens up a lot of doors. Okay, so let's unpack this core idea then. Instead of just, say, updating a database row, changing a user's address, right? Imagine you record every single action that led up to that current address. It's almost like keeping this perfect, unchangeable diary of everything that's ever happened in your system. What does that actually mean conceptually?
Yeah, it's a pretty big shift, actually. At its heart, event sourcing is a design pattern where the application's state, it isn't just saved directly, like a snapshot. Instead, that state is derived. You derive it by storing and then replaying this ordered sequence of immutable events. Each event captures precisely what happened, when it happened, and with what data. Think of events as just facts, like order created, payment processed, maybe address changed. They're not just data points, they're like historical statements about intent and action.
That makes a lot of sense. It's like having this perfect audit log baked right into the system's core. But why go down this road? Especially when, the standard way is just keeping the latest state, the latest snapshot. What's the real power you unlock when you decide to keep track of every single step?
Right. And that's where it gets really compelling. The advantages, especially when you're talking microservices built with Spring Boot, they're pretty significant. For one thing, you get this, unparalleled auditability. Imagine a situation where maybe a critical business decision was made based on data that turned out to be wrong. With event sourcing, you don't just see the now. You can literally rewind your system state, go back to any point in time, pinpoint the exact event or sequence of events that led to that specific data state. It's like playing back a perfect recording in your system's entire life. Makes debugging, compliance incredibly robust. And then there's this amazing flexibility. This part I find really fascinating. This pattern essentially, future-proofs your data. Let's say your business decides tomorrow they want to analyze customer behavior in a totally new way. Maybe understanding the sequence of product views before a purchase or how promotions affected certain order changes, things you didn't anticipate. You don't need to re-architect your core database. You project new read models from the event stream you already have.
You unlock new insights without messing with your current operations.
Wow, yeah. That kind of architectural agility, that sounds like a real game changer. So, okay, auditability, flexibility. What else does event sourcing bring to the party?
Oh, absolutely. There's also inherent decoupling. Events naturally set you up for asynchronous communication between your microservices. So instead of services making direct calls to each other, they publish events. They broadcast them to a shared message broker, maybe Kafka or RabbitMQ, and then other services just react to those events. It dramatically reduces those tight dependencies, boosts resilience, and for scalability. Event stores are typically optimized for append-only operations, which are super efficient. Plus, your read models, which are separate, can be fine-tuned for very specific queries. Making reads fast, this also gives you powerful reconstruction abilities. Being able to rebuild the entire system state just by replaying events, that means you can recover easily from major failures. It even makes handling complex schema changes over time much, much more manageable. And, within the Java world, Spring Boot, especially with frameworks like Axon or Spring Cloud Stream, they really do streamline the implementation. Makes these benefits a lot more achievable.
Okay, so let's connect this directly to microservices then, these small independent services that need to talk to each other and scale out. How does event sourcing specifically help them work better? What's its unique role there?
Right. In a microservices architecture, event sourcing often becomes, foundational. It enables a true event-driven architecture, or EDA. So services publish events like a user-registered event out to a message broker. Think of that broker as like the central nervous system for your microservices. And tools like Spring Cloud Stream, for example, they act as this universal connector. Connects you to Kafka, RabbitMQ, whatever. Simplifies how services broadcast or listen for those events. Then for state persistence, instead of just saving the current state in, say, a relational database, each microservice appends its events to a dedicated event store. Now, this could be a specialized data case, something like Event Store DB, or you could even use MongoDB or Postgres configured for append only. Inside Spring Boot, libraries like Axon Framework really help automate this, especially for what we call aggregates. An aggregate is just a cluster of related objects you treat as one unit for changes, like a specific order or a customer. All the events for that order or that customer get processed together consistently.
Right, okay. But you mentioned rebuilding state by replaying events. That sounds like it could be slow if I just want to query something quickly. Right. How's that handled?
Yeah, excellent question. That's exactly where read models, sometimes called projections, come into play, because querying that raw stream of events can be slow for certain reads. Yeah. So we build these separate denormalized, optimized views of the data, specifically designed for fast queries. For instance, if you need to quickly show all active orders on a dashboard, you'd have a read model structured perfectly for that exact query, and it's constantly updated by just consuming the new events as they come off the stream. This often goes hand in hand with CQRS command query responsibility segregation. That just means you separate the system's write path, where commands come in, from its read path, the query side. Think of it like having two different windows at the bank. One for deposits and withdrawals, the write model, and a completely separate one, super fast, just for checking your balance and seeing past transactions, the read model, specialized for different tasks. And this whole event-centric way of doing things inherently gives you amazing auditability and debugging, a complete verifiable history. Plus, it's kind of the ultimate enabler for loose coupling between your microservices.
Services communicate through these event streams, not tight, direct API calls. That fosters much, much greater resilience.
It's really clear event sourcing offers some deep advantages, especially for distributed systems. But why is it considered so critical for microservices in particular? What specific challenges, maybe unique to that architecture, does it solve so well?
It's critical because microservices, just by their nature, they're distributed, they're independently deployed. That brings complexity. Event sourcing hits several key challenges head on. Reliability is huge. Storing events means basically no data loss because you can always reconstruct the state. For scalability, that append-only nature of event stores plus asynchronous event processing, it's perfect for high-throughput systems you need to scale out horizontally. The flexibility we talked about, that gets amplified in microservices. It lets individual services evolve their own data models, create new read views without breaking other services. Auditability becomes almost essential, especially in regulated industries, or even just for understanding complex user journeys that span multiple services. And resilience, that ability to replay events and recover from failures, that's a lifeline in a distributed world where things can and do fail independently. And again, the Spring Boot ecosystem, with things like Axon, Spring Cloud Stream, it makes implementing this much less daunting, turns a potentially scary pattern into something practical.
Okay. We've covered the what and the why pretty thoroughly. Now let's get practical. If you're actually building a new microservice or maybe refactoring an old one using Spring Boot, how do you do this? What does event sourcing look like day to day for a developer?
All right, let's use that e-commerce example again to make it really concrete. Imagine a Spring Boot microservice that handles orders. Okay, first you'll need an event store. Now you could use a regular database like MongoDB or Postgres, but dedicated event stores like Event Store DB, they're really optimized for that append-only pattern. If you're using Axon Framework in Spring Boot, you define your order maybe with an add event source aggregate annotation. Axon then handles persisting the events related to that order for you. Next, you define your commands and events. So a create order command might come in from a user request. That command triggers some action in your service, which then generates an immutable order created event. Axon's command handlers are key here. They receive commands, process them, maybe do some validation, and then they emit the corresponding events. You have your event handlers. These are components that listen for and react to these events. So for our order service, an order created event might be picked up by an event handler whose job is to update a read model. Or maybe it's consumed by a completely different microservice, say a shipping service, to kick off its own process.
And for getting those events between your microservices, that's where message brokers like Kafka or RabbitMQ come in, wired up nice and easy with Spring Cloud Stream. They're the communication backbone.
Right, so those read models, those are the optimized views you mentioned for fast querying. How do they actually get built? What do they look like?
Exactly. So sticking with the e-commerce example, maybe a separate Spring Boot service subscribes to events like order created event and order shipped event. As it receives these events, it builds or updates a denormalized read model. Maybe it stores this in Redis if you need super fast reads for a dashboard, or perhaps in Elasticsearch if you need powerful search capabilities over orders. The key is, this read model is only for reading. All the state changes originate from processing that event stream. It's kept up to date by the events. And finally, for monitoring, you'd absolutely use tools like Spring Actuator, Prometheus, Grafana. You need to keep an eye on those event processing pipelines, your event store health. make sure events are flowing smoothly and consistently.
That example really helps visualize it. You can see how the different pieces, the commands, events, store, handlers, read models, how they all work together. But what stands out to you as the really tricky parts or the key things someone needs to consider before jumping in? It sounds incredibly powerful, but it also sounds like it adds some serious layers of complexity. Is this something that maybe makes it a non-starter for smaller teams, or are there ways to manage that curve?
Yeah, you've definitely hit it on a crucial point. Complexity, event sourcing absolutely adds layers, no doubt about it. You're managing event stores, message brokers, you've got this extra synchronization logic for read models. For a very simple CRU'd application, yeah, it's probably overkill, let's be honest. But for systems that have high auditability requirements or really complex business rules or systems you know are going to need to evolve significantly over time, for those, the upfront investment in understanding and implementing this often pays off big time down the road. And tools like Axon, they do significantly reduce the amount of boilerplate code you have to write. But the shift in mindset, that's often the biggest hurdle. Another really big consideration is eventual consistency. Those read models we talked about, the ones users often interact with, they're typically eventually consistent, which means there might be a slight delay, usually very brief, milliseconds perhaps, but a delay nonetheless, between an event happening and the read model reflecting that change. It's a trade-off you make for scalability and resilience, but it means you need to design your user interfaces carefully.
Maybe users need to understand they're seeing data that's eventually consistent, not instantaneously updated everywhere. Think about like a bank transfer. Your balance might update fast, but the full detailed statement line item might take a moment longer to appear.
That makes sense. It's a design consideration. And if you're storing absolutely every event forever, doesn't that mean your storage is just going to grow and grow? How do you manage that side of things?
You're absolutely right to think about storage growth. Event stores, yeah, by design, they grow indefinitely because you're always appending, never deleting events usually. This means you need strategies like snapshotting. That's where you periodically save a snapshot of posts as the current complete state of an aggregate, like an order. This allows you, when you need to rebuild the state of that order, to load the latest snapshot first, and then only replay the events that happened since that snapshot was taken. Instead of replaying potentially millions of events right from the very beginning, it's crucial for performance, especially for long-lived aggregates. And of course, development expertise is key. There's a learning curve. While Spring Boot and frameworks like Axon simplify things a lot, you still need a solid grasp of event-driven design principles and the specific tools you're using. It's not trivial, but the frameworks do handle a lot of the heavy lifting.
Okay, so let's try and wrap up this deep dive. Event sourcing, especially when you pair it with Spring Boot and its rich ecosystem. It really offers this incredibly robust, adaptable way to manage state in complex systems, particularly distributed ones. It's clearly not just about how you store data. It's more like creating this living, evolving narrative of your entire system. And its real strengths seem to shine through in that complete historical traceability, the inherent scalability, and that profound architectural agility you mentioned.
Absolutely. I mean, despite that added upfront complexity, the conceptual shift, the long-term benefits you get for system resilience, for rock-solid auditability, and for massive scalability, it really makes it a critical pattern to consider for any modern, complex, data-intensive microservice architecture. It's about building systems that aren't just functional today, but are inherently robust and genuinely able to evolve as business needs inevitably change over time.
So thinking about all this, it does raise an important question, doesn't it? Given the power and also the complexities we've discussed today, how might understanding event sourcing change the way you approach designing any system that needs to be truly robust, truly auditable, and genuinely future-proof in this increasingly dynamic digital world we live in? Something to think about.